Good morning to one and all. In this video, we are going to discuss about control strategies of chopper. Along with this topic, we are also going to discuss about problems which I have given in previous videos as practice problems. Control strategies are nothing but control methods, means how we are going to control the output voltage of chopper by using different methods. These control strategies or control methods are mainly classified into two types. Types of control strategies. These are time ratio control as well as current limit control. The concept of these methods are very simple. The name of these methods itself gives the concept, that is time ratio control. In this method, we already know time ratio. Time ratio in the sense duty cycle. It is the ratio of on time of the chopper to the total time of the chopper. The output voltage of chopper can be controlled by using this method by controlling the on time of the chopper as well as total time of the chopper. And second method is current limit control. That is nothing but in this method the output voltage is going to control by controlling the charging current as well as discharging current of the chopper. Now consider first method, that is time ratio control. We know time ratio in the sense duty cycle, that is the ratio of on time of the chopper to the total time of the chopper. Depending upon this ratio, this first method time ratio control again classified into two types, that is constant frequency control method and second one is the variable frequency control. Constant frequency control method also known as pulse width modulation technique and variable frequency control is also known as frequency modulation technique. Now we are going to discuss about each and every technique. Now consider constant frequency control, that is also known as pulse width modulation technique. The concept of this method is very simple, that is in this method the output voltage of chopper can be controlled by controlling the on time of the chopper by making total time of the chopper as constant, that is on time is variable and total time is constant. This method also known as pulse width modulation technique. Why? Because in this the width of the pulse is going to change, so it is called pulse width modulation technique. Now consider waveforms which are related to constant frequency control technique. These are the waveforms related to constant frequency control method. In this, Vs is the input voltage of chopper and V0 is the output voltage of chopper. Here we are going to observe the output voltage for different duty cycles. That is, duty cycle is 25%, 50% and 75%. In this case, we are going to control the output voltage by controlling the on time of the chopper by making total time of the chopper as constant. Means by varying the on time of the chopper we can get the variation in the output of the chopper. Now consider first case, that is duty cycle is 75%. In this case on time is 75%. During on time of the chopper we are going to get the output voltage which is same as the input voltage. During off time of the chopper the output voltage is 0. Similarly, if we increase the duty cycle to 50%, means up to 50% of total time period we are going to get the output voltage which is same as the input voltage, and remaining 50% of time period the output voltage becomes 0. Similarly consider duty cycle is 75%. In this case up to 75% of duty cycle we are going to get the output voltage, and remaining 25% we are going to get the 0 output voltage. Means in these cases we are going to vary the on time. Okay, depending upon the on time of the chopper we are going to get the output voltages. And in this case, in each case the width of the pulse is changes, that is in 25% we are getting up to this one is the pulse width, in 50% this one is the pulse width, and 75 this one is the pulse width. Means the width of the pulse is changes, so it is called pulse width modulation technique. This is about controlling the output voltage by using constant frequency control method. Second method is the variable frequency control. This is also known as frequency modulation technique. In this technique, we are going to change the total time period of the chopper by making either on time or off time of the chopper as constant. Okay, it is also known as frequency modulation technique. We are going to conclude why it is called frequency modulation technique by using waveforms. First, consider on time of the chopper as constant by controlling the output voltage of chopper by using variable frequency control method. These are the waveforms related to controlling the output voltage of chopper when on time of the chopper as constant. Here Vs is the input of the chopper and V0 is the output of the chopper. We are going to observe the output voltage of the chopper for different duty cycles. In all the cases, we are going to make the on time of the chopper as constant. Here T1 is the time period of the chopper when duty cycle is 25%. T2 is the time period of the chopper when duty cycle is 50%. Similarly, T3 is the time period of the chopper when duty cycle is 75%. Here T1, T2 and T3 are not equal. Means here we are going to vary the total time period by making the on time of the chopper as constant. Similarly, consider controlling the output voltage of chopper by using the variable frequency control method by making the off time of the chopper as constant. Here Vs is the input of the chopper and V0 is the output of the chopper. We are going to observe the output of the chopper for different duty cycles. In all the cases, we are going to make the off time of the chopper as constant and we are going to vary the total time period of the chopper, that is T1, T2, T3. For each and every duty cycle, we are going to get the variable output voltage across the load. That is, for duty cycle 25%, we are getting this amount of output voltage. For duty cycle of 50%, we are going to get this amount of output voltage. For duty cycle is 75%, we are going to get this amount of output voltage. Means by making the off time of the chopper, by varying the total time period, we are going to get the variable output voltages at the output. Here T1 is not equal to T2 is not equal to T3, means we are using the different time periods, and we know frequency is the reciprocal of time period. Here for different time periods we are going to get the different frequencies. So this method of control is also known as frequency modulation technique. In this way we are going to control the output voltage of the chopper by using variable frequency control method by making on time of the chopper as constant as well as off time of the chopper as constant by varying the total time period of the chopper. Coming to second method for controlling the output voltage of chopper, that is current limit control. The concept of this method for controlling the output voltage is very simple. In this, the output voltage is going to control by controlling the current values. That is, the output voltage is depends upon the charging and discharging currents of the chopper. Here charging and discharging currents depends upon the inductance value. If the inductance value is less, the time required for charging as well as time required for discharging the current is less, means we are going to get the less amount of output voltage. If the inductance value is high, means the time required for charging as well as time required for discharging is more, means we are going to get the high amount of output voltage across the load. This one we are going to discuss by using the waveforms. These are the waveforms related to controlling the output voltage of chopper by using current limit control. In this, I0 is the load current and V0 is the load voltage or output voltage. In this case, consider inductance is low. If the inductance is low, then load current takes the less time for charging as well as less time for discharging. This is the time required for charging the load current. Similarly, this is the time required for discharging the load current. whenever this load current reaches the minimum value, that is nothing but I minimum, then chopper starts conducting and we are going to get the output voltage across the load. Again, whenever load current reaches the I maximum, that is nothing but maximum charging current, then chopper starts commutating and we are going to get the discharging current and the voltage across the load is 0. Again, whenever load current reaches the minimum value, again chopper starts conducting and we are going to get the output voltage across the load, which is same as the input voltage. Okay, these are the output voltage waveforms for low amount of inductance value. Similarly consider if the inductance value is high. Again, I naught is the load current and V naught is the load voltage or output voltage. Okay, if the inductance value is high, then load current takes more time for charging as well as more time for discharging. This is the time for charging and this is the time for discharging. During charging period, we are going to get the output voltage which is more than the output voltage if the inductance value is less. Whenever the load current reaches the minimum value I minimum, then chopper starts conducting and we are going to get the output voltage. Whenever load current reaches the I max, then chopper starts commutating and we are going to get the 0 output voltage. Again, same cycle going to repeats. In this way, we are going to get the variable output voltage and control output voltage at the load by varying the charging and discharging currents of chopper. These are the control strategies of chopper, means output voltage going to control by using different methods. In previous videos, I have given some problems for your practice. I think everyone completed those problems. If completed, please check your solutions with the given solutions. In that first problem is depends upon the choppers, means we have to determine the type of the chopper by using given data. Here given data is input voltage, on time of the chopper and off time of the chopper. It is one of the gate bit for 2 marks and it is very simple but very tricky question. Why? Because if we know the input and output relations of the chopper, then only we can get the type of the chopper. But in this problem, we have to determine the type of the chopper. Without knowing the type of the chopper, we won't get the relation between input and output relations. Without knowing the input and output relation, we won't get the type of the chopper. And the options given are step down chopper, step up chopper, both or none. Okay, for this question, the answer is both. How means we are going to discuss. We know formula for duty cycle, that is on time of the chopper by total time of the chopper. We know on time and off time of the chopper in the given problem. So substitute all those things, we are getting duty cycle is 0.25. If we consider step down chopper, then we know the relation between input and output is V0 is equal to duty cycle into input. Okay, we know duty cycle value as well as input value. By substituting this one, we are getting this amount of voltage which is less than the given input voltage. Okay, this amount of voltage is possible by considering if the chopper is step down chopper. Similarly, by considering step up chopper, we know the relation between input and output, that is output is equal to V in by 1 minus duty cycle. Okay, by using this formula, we are getting the output voltage is 328, which is more than the given input voltage. This amount of voltage is possible by considering given chopper is step up chopper. So by using the input voltage and on time and off time, it is not possible to conclude the type of the chopper. So by assumptions of step down chopper and step up chopper, we are getting these voltages. So the option is both, means it is a step down chopper as well as step up chopper. Coming to second problem, that is depending upon the rectifier, that is the ripple factor of the single phase half wave rectifier is 1.6. Then we have to determine the form factor of the rectifier. We know form factor, that is form factor, it is the ratio of RMS voltage to the average voltage. But in given problem there is no data for RMS voltage as well as average voltage. So there is no possibility for finding the form factor by using this formula. So we have to go for one more formula which gives the relation between ripple factor as well as form factor. That is, in rectifiers we know this formula that implies the relation between ripple factor as well as form factor, that is given as ripple factor is equal to square root of form factor square minus 1. Just square on both sides and find out the form factor. Then form factor is equal to square root of ripple factor square plus 1. In given problem we know value for ripple factor, that is 1.6. Just substitute here and find out the form factor value. So form factor is equal to 1.88. This formula is very important in gate point of view, which indicates the relation between ripple factor as well as form factor. These type of problems are very important for gate point of view. Coming to third problem, it is related to string efficiency. That is, find the number of SCRs in a string which is having the derating factor of 0.6 and total current carrying capacity is 4.6 kiloamperes and current flowing through each SCR is 0.6 kiloamperes. Okay, for finding the number of SCRs, first we have to know the type of the connection. By knowing the type of the connection only, there is a possibility for finding the formula for string efficiency. Here type of the connection is determined by using the given data. Here given data is in amperes, so the type of the connection is parallel. If the given data is in voltages, then we have to consider the string efficiency formula for series connected SCRs. Here given data is amperes, so type of the connection is parallel. Now consider the string efficiency formula for parallel connected SCRs, that is given as the ratio of total current flowing through entire string to the product of current flowing through each SCR into number of SCRs. Here we know total current carrying capacity as well as current flowing through each SCR. We have to determine the number of SCRs, that is string efficiency. But there is no data for string efficiency, but there is a data for derating factor. I think everyone know relation between derating factor as well as string efficiency. By using that relation, find out the string efficiency value. After finding the string efficiency, just substitute in this formula. I think everyone know the relation between derating factor and string efficiency. That is, derating factor is equal to 1 minus string efficiency. From that, find out the string efficiency. That is, string efficiency is equal to 1 minus derating factor, that is 0.4. After finding the string efficiency, substitute all the values in a string efficiency formula. That is, string efficiency 0.4 is equal to total current carrying capacity by number of SCRs into current flowing through each SCR. Here N indicates the number of SCRs connected in a parallel. From that, find out N. N is equal to, we are getting 19.1. But it is not possible to connect the SCRs in a fractions. So consider 20 SCRs which are connected. 19.1 indicates the 20. That is, 20 SCRs are connected in a string. That is the answer for number of SCRs which are connected in a string. Okay, this type of problems also very important in gate point of view. These are the topics in 4th unit. In next lecture we are going to start the 5th unit, that is nothing but inverters. Thank you.